No, if you're exempt or think you'll be exempt, you take the test.
For me?
Well, what I'll do if you're exempt is, no, it's not giving you an exam. It's, everyone else is taking the test within their exam.
I want to see that.
But
What are they gonna do now?
they're reviewing and you will review during the first half of class. They will continue to review while y'all take the test in the second half of class.
All right, push me, Steve.
So you will have extra time to review for that test.
So what's
There's
that?
demonstrate understanding today. At the end, after we finish going over some stuff.
Monday.
Sounds good. Yeah.
So what Wednesday?
All right.
and Friday, maybe?
Say again, Trey?
When does exam?
Y'all's is Monday.
So what's Wednesday, Thursday, and Friday?
Makeup day.
Wednesday, Thursday,
Yeah.
Wednesday, Thursday, yeah, makeup exams.
Friday, what's Friday?
Friday, you shouldn't be here.
Friday is just teacher finish up days.
Yeah.
Alright, so assessment changes. So remember, test is only tomorrow if you are likely exempt. Again, we are going to go over the demonstrate understanding, tomorrow to start the day, go over some things that I'm noticing as patterns of issues. Hopefully, we understand inverses better so that honestly this logarithm stuff is not much new. So remember, all a logarithm is what? Inverse of an exponential, right? And so if we understand what an inverse is, nothing has changed from what we have been doing. It's just a different type of function, okay? So, but we will review for the first half of tomorrow. And if you're taking the test, then we'll take our test. And if you are continuing to, if you're not likely to be exempt, you're gonna just keep reviewing for your final. One note I will make is, quickly before we get started with,
You put out the test in?
no, I did not yet. I'll do that.
We gonna
Start
get
off
this
today.
thing?
Excuse you, sir? Excuse me, sir?
I need to
Say it one more time.
Bless you.
Okay. Well, that's why we're doing our test tomorrow. Those of y'all who are likely to be exempt. What do you mean?
Right here? It's the hardest conversation.
That's why we're taking the test tomorrow.
Because I got 10 actions.
Alright, really quick notes. Marty, can you let Chandler in, please? So I do want y'all to see this. Amari, Chandler.
Oh, my bad.
Okay, so please remember, this Mathia is still here,
I'm glad
right?
I did my last night.
Okay, well I need to update these arrays as well, but this Mathia is here. Unit 1, linear exponential quadratic functions. That was the first major unit that's going to be on your midterm, or your final. Then there will be solving quadratic equations, which I don't have that in here yet, but I can. Here, Algebra 2, Unit 5, this is all those polynomials and the features of polynomials in behavior, relative max, relative min, the intervals of increase, decrease. If you struggled with that on your test, which I will give that test back today, or if you didn't take that test, then you're going to have to show me that evidence of understanding on the final. But all of that is here. I still have 1, 2, 3, 4, 5, that yellow there, so 5.
Hey, you gotta put grades in for this, for Matthew?
Yes, I still have to. 6, 7, 8 of us who have not even logged in on the Mathia.
Hey, my name.
If you have a, if you have a green, that means that you have not completely finished that workspace. Gray means you have. So make sure that you're paying attention to what you're looking at. Algebra 2 Unit 5 was the polynomial stuff. Right here at the end, what did I just open to help you get some practice? Can you see what that says, counsel?
Average of 2
Inverse and logarithms. So maybe work on it during advisory, or try it on
How you
your
doing the
phone.
Matthew grade?
Say again.
How you doing the Matthew grade?
Well, I mean like at home or something. I'll look later, but because I need us to get going. So try it. You can try it on your phone. I if you have a laptop or a tablet at home, then you can do it on that. It doesn't have to be a school device. You just have to go to clever.com, sign in, and go to Carnegie Learning. So you can do it on any device.
You can do it.
For it to get full credit, all got to full.
No, it doesn't have to all be full. You'll get, for full credit, yes, but you get partial credit based on each workspace you finish.
Alright. So all mine, I got like 300.
Okay.
I ain't using that.
So, let's get going with this today. Let's see here. So, remember with inverse functions, we need to restrict the domain of a function to make it invertible. As a quick recap with that, right here, would I need to restrict the domain of this function to make it invertible? Why not?
Because it
It already passes the horizontal line test, which means the inverse will pass the vertical line test. This is, what's another name for this function that passes both vertical and horizontal line test? A one-to-one function, right? Notice that vocabulary is right here. Do you have to compose two functions to determine if they are inverses? No, Mr. Kenny. Remember, I took that one out. How do we determine if two functions are inverses graphically? This is kind of like the foundation of all things. Okay, we can use a table, but what would you have to see in the table? Or see in the graph?
What?
Oh, inputs and outputs transpose.
So remember, if we're looking at those tables or we're looking at those graphs, the inputs and outputs have what? Transposed because of what? Like, what's happening graphically?
Oh, it's being reflected.
Being reflected across
Y equals
y equals x, and so those inputs and outputs transpose. So don't forget, that has not changed. Notice, what two types of functions, hey guys, the whole point of our phones being up is so that we're not distracted. Thank you. Okay. What type of functions did I just graph up here? Exponential and, that's not linear, it's a what? Logarithm, right? Remember how that logarithm is that inverse, right? The reflection across y equals x. So we need to recognize that this is the inverse function's proficiency scale, but that still holds for all the logarithm stuff that we're doing right now. Graphing the inverse of a function graphically or tabularly, or using it to graph. What do we always need to remember, KK, about inverse functions to be able to graph it, to be able to graph it? What happens? Guys, we got to know this off the top of our head. We've been working on this every day, multiple times a day. What is true for every inverse function? The x and y transpose. To be an invertible function, it has to be one-to-one. But if I give you a graph or I give you a table and I ask you for the inverse, what are you going to do?
Transpose.
Transpose what, KK? X and y, the inputs and outputs. Ma'am?
Which one?
What? So right here, you see how this passes the vertical line test? So one input maps only one output. You see how it also passes the horizontal line test? Every output mapped from only one input, so it's one-to-one. It's one in both directions. Okay. Say again. Here you go. Is it the inverse one or the log one that you need? Alright. And then solving equation for the input. By the way, guys, if you're solving an equation in general and you only see one variable, you're going to use inverses. Don't make it more complicated than that. We're going to do some practice with that today. And then we got our vocabulary, identifying features of functions. What are some of the features that I could ask for, Kyson? Give me one feature of a function that I could ask for.
Oh man, got my thing out. Hold on, give us some time.
But Kyson, if you think about it, what features, like definitely get that out, but what features could I ask you to be analyzed for? Alright, when we come back to you, Kyson, after someone says another one. What do you say, Des? X-intercepts. Kyson, you know any other features? Y-intercepts. Dewan, give me another feature.
Wait, we talking about like the what you call it?
The features of a function that I could ask you to analyze. I heard X-intercepts, Y-intercepts.
Like in behavior?
So in behavior, right? As X goes to something, what does Y go towards? Trey, give me one more feature that I could ask you for.
About what?
Feature of a function, dude.
Feature of a function.
We said X-intercepts, Y-intercepts, in behavior.
Domain and range.
Domain and range, right? Domain referring to all the what, Mason?
X-intercepts, or,
Well, domain is which one?
X.
X values, right? Not x-intercepts. X-intercepts is only where that function does what? Intersect the x-axis, right? So be careful about that language. So x values, range is y values. Don't forget, it's not going to be here, but it will be on the final if you have to take it. Relative max and relative min. And absolute maximum and absolute min. Can. I was saying, you just said what without thinking about it. I know you know this. What have we also called the maximum min? Extrema. And we talked about it one time as those terms, right? Wherever it turns, it's going to be a max or a min.
Yeah.
Okay? And then we use all this to now start talking about logarithms. Now, we know that a logarithm is the inverse of an exponential. But if I ask you, hey, what is log base 3 of 27?
58.
Log
Nine.
I know it. I know it. I know it.
Why is it 3, Cam?
I know it.
Okay, so you said 3 times 3
9.
is 9 times 3 is 27. But how could I rewrite that? 3 to the third. So which part of this tells me that log base 3 of 27 is 3? The exponent. Remember, so the base is 3, but what is a logarithm? A logarithm is an exponent. That's why logarithms are the inverses of exponentials. Alright. And that, so I will ask you to evaluate logarithms with integer exponents or to explain it. We're not going to estimate logarithms. This is the last major thing that we're going to do a little bit today and give you some practice with. Okay? And by the way, don't forget I told you that we're not doing natural logarithm. We're not doing Euler's number, transformation, or properties of logarithms. So you don't need to know those vocabulary terms. We're not doing it. We're taking out natural log, Euler's number, transformation, and properties of logarithms. How about I do actually want you to learn something? So no. Alright. So, out of the textbook pages,
Wait, the jukebox.
just going to quickly touch on a few things from yesterday. This is page 125. Is where we're kind of starting as a small recap. We're going to go past this page in a second. That's just to give you a reference.
Page what?
127, or 125 right here. Yeah, I think we turned toward that out on Friday.
So why are we going back to it?
Because I just said I'm going to do a quick little recap with some of these details. So, that's not, oh, sorry, that's for third block, we already did that here. So 129 is the page that I want to quickly look at. And so this is going to help build us into what we're about to discuss. By the way, Alyssa, do you have the log proficiency scale? Okay, so you just didn't have the inverse one. Alright, so, what you need? Go. So, here we have what type of function, Yana?
I don't have a log.
You said 120 what? What is it, Chandler? Be careful of the language, not an exponent, an exponential. So, hey guys, let's clarify this, okay? We need to be clear on the difference between an exponent and an exponential. X squared, that power function, has an exponent of 2. When I say exponential, what's the difference with an exponential function? A variable where? Because there's a variable here too. So the variable is in the exponent. When we say exponential, the variable is in the exponent because that means I'm going to keep multiplying by whatever that base is forever. The number of times I multiply by that base can change. So, looking at this page, we have an exponential. We already know, Sean, what's the inverse of an exponential function?
What's the inverse?
Of an exponential function, yes sir.
Wow.
Log.
Logarithmic function, yes sir, yeah. The inverse of the exponential is a logarithmic function. So how am I going to get the graph of that logarithmic function, Mason?
By Brian.
Oh, are you gonna get that graph?
Yeah.
Oh. You're gonna have to square, you're gonna have to figure out what your base and your variable is to figure out how you're gonna get that.
Not if I'm already given the graph.
Oh, you can do,
Okay. Okay, so, hey guys, if we're talking about inverses, what's a word that should come to our minds every single time? Transposing, right? So, you can make a table, you don't have to, right? But, the very first point here is -2, 1 divided by b squared. Because, by the way, what is a negative exponent? It's repeated, not multiplication, division, right? A positive exponent is repeated multiplication. That negative, I know you did. Negative exponent is repeated division. Then I have -1, 1 divided by 1b. 0, 1, 1b, and 2b squared. Right? Because literally, my input is the what? No, my input is the exponent, right? So that input of 2 gives me a b squared. And I know this is going to sound crazy, because Mason, you're like, we got to know what our b is, don't we? But we actually don't here, because this is just a generic exponential. Even without knowing my base, Cam, how could I get the inverse function? We already said it a couple times. What are we going to do? Morning, Jason.
Look at the.
I'm asking how am I going to get, so first off, we need to notice this notation right here. What does this mean right here? The inverse of h of x. My question is, how am I going to get that inverse function? Be able to graph that inverse of h of x. I'm going to transpose what?
The problem.
So the inputs and the outputs. Guys, every time we're talking about those inverses, inputs and outputs transpose. So, counsel, give me my very first point here.
-2, 1 divided by b.
Yeah.
That first one.
Okay? Anybody want to add on to or push back on that? Ah, that's right. It's an inverse, so I'm supposed to what?
I was just telling you what it was.
Oh, but I was asking what is the inverse function? So I need to transpose them. Right? And Jaden, you may need to grab some pages out of this book.
Ew.
Okay. 171, I think it was 171 to 182, if you don't already have it. 20 what?
I think 203.
204 and 213?
Well, basically 203.
I think. Okay. And if you need a different book, there's some up here. Okay, so, yes, Chandler. So, remember, what does this fraction bar mean?
203.
Divided by. So, remember, if I were to do b squared, that's b times b, multiplying 2 b's. But if I do b to the -2, I'm not multiplying, I'm doing 1 divided by 2 b's. So a negative exponent just means division. Okay? And so we don't know what the b is, but it's going to hold out. So you're already noticing that 1 divided by b, what is the output then? -1. What does this point become? 1, 0.
1 0.
Then
6 1.
that's not a 6.
B1.
I think
b
that's a B.
1 and b squared 2.
Bad.
Okay. So what I would remind you of, right, Janiyah, what is the reason that our inputs and outputs transpose? You remember?
Look at me.
Jacqueline, can you help us out? Remind us what causes our inputs and outputs to transpose? It's the what? Function. It's something with the function. What are we doing to the function, Des? We're what? We're reflecting, right? Remember, we're reflecting across that line. Y equals
Got it.
x. And so, Mason, this is why we don't need the exact value of b, because I can reflect across this line. and approximate it. I don't need exact, I just need to notice it's a reflection across. Notice it's perpendicular about the same distance to the other side.
Perpendicular.
And so notice this would be 1, 0. This would be B 1. This would be B squared, comma 2. 1 divided by B, negative 1. So notice my inputs and outputs are just transposing. Does that look like a reflection across y equals x? Is it perfect?
Nope.
Am I sweating it?
Nope.
Nope. I just need us to recognize that it's that reflection across y equals x. And again, even if you're not writing those notes down, I would highly recommend it, but at least make the note to yourself. What's the major idea happening here? It is an inverse.
It's reflecting.
So we have a reflection
So y equals x.
across y equals x, causing inputs and outputs to
Transpose.
Exposure.
Transpose.
So does that change from power functions to exponentials and logarithms?
Yep.
Is it?
No.
Jose, isn't that exactly what we did with our power functions to get the radical functions? I mean, all the stuff I wrote on the board, maybe this table, the inverse graph here, but the major idea that we need to recognize is, even though we're dealing with a new function, we're dealing with exponentials and logarithms, right? What's really happening? A reflection across y equals x, causing inputs and outputs to transpose. That's not changing. We need to recognize that. Trey, you got all those notes down? Okay.
Yum, yum, yum.
Got all that down, Chandler? Did me ask a question before we start writing it?
Hey, can I put it on the example?
You can.
I got it from the nigga ones.
Say that one more time, Chandler. Well, I mean, if you read it, it says evaluating logarithm. We're probably not going to get there. Solving log equations. Solving exponential equations. About to talk about. Yes, sir. I know you're hype, aren't you?
How long that man be gone?
It's been a whole school year, I know.
I'm not talking about that. How long that man be gone in the gym? Too long.
You think you've been in school too long?
This week. I've been going to Hillcrest since 6th grade.
Well, you went to Hillcrest middle.
I've been in Hillcrest since 1965.
Same
Hillcrest was
Yeah, 2 years ago yesterday.
What happened to me? Your CDA?
Hey, what? What are you talking about?
Hey, Juwan, you got all your notes that you need?
No, I ain't
You
even
got all
writing
your
no
notes you need? Hey, Julian, do you want to turn your desk so you can actually see the board?
What, I got to?
I said, do you want to?
No, sir.
Okay.
Walker making 2 in the can.
Can you be on PlayStation?
Xbox One.
Oh my god, you nasty.
I don't put you on the can't wait.
Look at it.
Yes, Chandler.
Look at it.
So, hey, we need to notice this. Excuse me. Chandler's asking a question. Notice, Chandler, this says h of x. But you see how this has that superscript of -1? Remember that superscript there means the inverse of h of x, which is why the inputs and outputs have transposed. I'm clearly showing that these are related. I'm showing that this is the inverse of h of x. Okay?
Finally finished.
So, you see, notice that superscript here. Right, because that's the original function. That superscript only means the inverse. So, original function, inverse. Okay, really quickly, we're gonna do a simple one to start here. And then we're gonna do some practice in a second. H of x equals b to the x.
Who she dating? Who that Sean? That's your phone?
My phone on, you don't even got that. Yep, you know, like,
So h of x equal to b to the x. What's the first thing I need to do if I'm trying to find the inverse
B
equation?
to the X.
Say again. Transpose my what?
X to the B.
Inputs and outputs.
Inputs and outputs. So I'm going to rewrite this as y equals b to the x.
phone ain't even know
I
what
thought-
trying to talk.
So, what did y'all say I need to do once I have y equals b to the
X to
x?
the B.
What's the difference? I thought
Ain't that right?
like same thing.
But what do we need to do with our inverses? We need to transpose our inputs and outputs, right?
X to the
I haven't yet. That's why I'm asking, what do I need to do now? I rewrote it as a y so that I can easily say, hey, that y becomes what?
B. X.
What does that x become?
X. Oh, wow.
So I'm just pointing out, I'm rewriting it with that y so that it's easier to transpose.
Dude, that was close.
If you are comfortable, counsel, going straight from here to here, am I okay with that? 100%. Okay, you can do that. You can skip that step if you want. All right. What do I need to do though to find the inverse equation? By the way, this is on the very next page at the top.
Oh, see what you gotta do is, you gotta do what you gotta do.
I know, but if I want an inverse equation, what do I need to use? I need to use a logarithm because I need what? Inverse operations, right? If I want the inverse equation, I just gotta use inverse operations. So, right now I have an exponential. What's the inverse of an exponential? Logarithm.
Logarithmic.
What base does this logarithm need?
Logarithmic.
Where?
What's the base of my exponential?
Y. It B.
B. So what's my logarithm base?
B.
Oh,
They have, the logarithm and the exponential have to have the same base to be inverses. You're messed up.
Can I please go to the restroom?
Why didn't you go before class?
Because I was gonna be late.
You were sitting there talking
What you talking about when?
before class.
You telling me grab the book? My fault.
Yeah, but if you
I was
went
trying
into
to
the
do the shit,
bathroom,
bro.
you were talking.
So why would we
When you could have been using the restroom and then come back to get the book.
Oh.
Go on, go quickly and get back here.
Yes, sir.
why would we X equals Y?
You got 10 seconds.
Log base b of x equals y, which notice I rewrote that using the inverse function notation. I'll wait here a second while you take those notes. Yes, Chandler?
He draws a diagram that shows
That's great.
What do you, squares the boxes.
Yeah, what do you do?
Oh, what?
So like, well,
Where did we get 4 from?
there is no 4.
Oh, that's 1.
Yeah. So, why do you think we use the B, letter B right here? What word did you just use that starts with B? Base. Whatever is the subscript of the logarithm is my base.
That'll be the first number before the exponent, right?
So if we're rewriting as an exponential, it'd be B raised to some power.
So,
And remember, what is a logarithm equal to? So that y is my,
exponent.
so B raised to the y, my exponent would have to equal x. These are telling the same story right here. Okay? So notice that logarithm and this exponential are telling the same story. Sometimes one is easier than the other.
I have a question. Can you do that?
Ma'am.
You added a log B over there.
Well, I took the log base B of both sides, yes ma'am.
Wait a minute.
We're about to do some practice with it. We are. You're about to see it. Huh? It's right there. Notice I said it's equal to y, and then I rewrote it with the inverse of h of x to show it's the inverse of h of x. If you stop with the y, I'll be okay. What's confusing you?
Okay, this is good.
Okay, sounds like we need a little bit of individual practice, which I'll support you in. Mason, can you let the one in? So,
It was like 30 seconds. You put it there 20 seconds ago.
really quick note, hey guys, really quick note because we're about to see an example of this. Do not forget, if there is no base written with the logarithm, what's the understood base?
10.
Base 10, and that's called my
Logarithm, common logarithm.
common logarithm. So if there's no base written, it's understood to be base 10, and it's called my
Common logarithm.
common logarithm. Okay, so I know some of us need some practice with rewriting it. So we're gonna look here at, this is page 171 or 172, to give you that practice. This is what, one of the things you've just torn out. It's not crazy stuff.
I'm reading this. Why would they come up with this? Wow.
It's actually a lot of it was developed to help us with astronomy. There's a lot of properties of logarithms that it really, really helps with astronomy. There's a lot of other reasons for that. So, page 172. I'm just going to do this first one with you. Nope. You may later, but not right now.
No calculator?
You will eventually need one, but just chill for right now. Okay. Yes, Chandler. The subscript is the base, but the subscript is there. So, remember, the exponential and the logarithmic are telling us the same story. So when I look here at page 172, I'm trying to rewrite this exponential as a what? Logarithm. So when I look at this logarithm, what base would this logarithm have?
10.
Base
12.
12, right? The base here is 12, so my logarithm has base 12. And do not forget, because I'm going to come back to what's called the argument in a second, but what in general is a logarithm equal to?
Snap back to him.
An exponent, right? So what is this logarithm going to equal? 2, my exponent. Because remember, what was my input has just become my output. And what was the output is my input.
Yes, sir.
So log base 12 of 144 is equal to,
Oh, that's easy.
no, log 2, right? Isn't my exponent 2?
Yeah, that's what I mean.
Okay.
I can't
So,
do them.
to help y'all, I'm going to give y'all a few minutes, do as many of these as possible, and I'm going to come around, support you, talk with each other about these, and we can come back together and go through them, ask the questions you need to when we start going through it. But I need you to take a few minutes practicing these. It helps, Julian, when we actually have the sheet of paper out that we need. Kyson, it helps when we're awake.
It help a lot.
So one thing really quickly.
Whoa!
Your logarithm, notice here with this logarithm how the arguments directly align with the logarithm. You need to make sure you're not making it almost like a superscript next to it. Write it log subscript 12, and then the 144 is right in line with the log. So like this is the right idea, but the writing of it doesn't matter.
Oh, no, I hope I
It needs to be
don't
in
fall.
line with the logarithm.
Yeah, what?
Would you write
Oh, by the way, guys, do the left-hand column as well if you already have, if they give you the logarithm. Hold on one second, I'll be there in a second. Let me tell you, so remember, what does a logarithm equal? It equals an, what's that 2 right here? It is the exponent, right? Did you write that this logarithm is equal to an exponent?
That'd be a fraction.
That was easy.
So,
We remember that.
we need our, this 12 right here was the base of this exponent, right? So, what's the base of this exponent? So this is log base 10. Right? And what was my output is becoming my, and what was my input becomes the output. Remember how the algorithm is equal to an exponent.
Now, Julian, do your work.
Okay.
What you think of it?
Hey.
Miss Ken, I
You
got
really want that on the internet when since I'm recording?
I'm sorry.
Come on.
Miss Kenny.
Dang.
Sir.
Which day you were going? That's-
Sir.
you ain't get my
I
shit.
forgot I was on you.
How'd it go?
Going to jail anyway, boy. I don't know.
What?
I'm ready for the jail.
Fix it now. We're high schoolers.
Dang.
Act like we're in 11th grade.
We are high schoolers, y'all.
Like,
We graduated, man.
Y'all,
Tripping.
man, start with that nigga too.
We finna graduate, man. You tripping.
like,
You said
Nigga too.
I gotta hear
Negativity.
I said nigga too.
Don't even answer that.
You said nigga
No.
too.
Yeah.
that's not what I heard.
I'm about to pick it up. Right.
I feel tired of listening to you.
Tell him pick it up right. Tell him pick it up right, Miss Kenny. Look, you all know my paper, Miss Kenny. Look, Miss Kenny, you all know my paper.
You're close.
This is on camera, guys.
But whatever the base is, the base of my look.
Oh, this kid look easy.
What was my output?
Put the X in parentheses. Oh, what X? Why you got the X outside?
Don't worry about that. That's
Twin, you
the
supposed to do like you
natural
did
law
anyway.
that's coming.
I didn't what I did that.
I'm so confused on what's going on with your paper.
Hey guys, don't worry about the one that says LN. Yeah, that's the natural log that I told you we're not covering. Yes, Jacqueline.
Did I do that? Did you come check
You don't
this?
need
We're about to go over.
Look, man, look.
Can we go over it, and if it's still confusing, ask a question? We just need to get moving a little bit. Okay.
You gotta get moving.
Alright, thanks, Kevin. Alright, so I'm going to go through a couple of these and rewrite them. Please ask a question. And I'll go ahead and tell you, some of these may not make complete sense because we didn't get a chance to study all the concepts that explain it, but you can always rewrite the logarithm as an exponential. So this would be 16 raised to the 1/2 is equal to, and so this is something we didn't actually get to cover, but this exponent of 1/2,
It's dividing it.
it's not dividing, it's actually a root. Specifically, it's the second root of 16 to the first. That's where that's coming from. Okay? And notice, what is 16 to the first? 16, and what's the square root of 16? That's where that's coming from. So what are called, this was one of the things I wanted to cover, we just didn't have time, but these are called rational exponents. They're just square, or they're roots. They can be square roots, they can be cube roots, they can be whatever kind of root. Whatever the denominator is, that's my root.
Whatever kind of root.
So this one here would be log base 10 of 100,000 is equal to 5. Now, I will point out, I could just write it this way.
Gotcha. Did you say 10?
Notice I didn't write a base with it.
Did you say 10,000?
Because the one is.
Not 1.
Because
The base is understood to be 10.
100,000.
So remember,
You said 10,000.
the common log is understood to be base 10. So if no base is written with it, it's a log base 10. Yes, Chandler?
Now, you said that was 10,000.
Correct.
Oh.
What do you think about this? Larry?
I thought I heard 10,000.
Okay.
I said 100,000.
Log base 2/3 of 8 divided by 27 is equal to 3.
I didn't get that.
Just in the middle of this.
Julian can do 50 push-ups. He worked 10 bucks.
No, it's not.
What's your question, Janai?
I don't get the 1/2. I don't get what you are doing the half.
Hey, excuse me, I'm trying to teach and I got a conversation so I can't even hear what Janai is asking. So Janai, what's your question?
I was saying, I don't understand when we started doing the half.
Well,
Me,
let me ask you
I
this.
write it out.
Do you understand that it's base 16?
Yeah.
Do you understand that the exponent is 1/2?
Mhm.
Do you understand that this is 4?
Right.
That's all I need from you right now.
Okay, so what about the one you just did?
Same thing, base is what? 2/3?
2/3.
The 8/27 is my input now, my argument, and I'm equal to the exponent.
Well, I got
Now,
40.
to explain, and so Janai, there is a reason why. So remember, if I cube something, that just means I'm multiplying it how many times?
Twice.
If I cube it?
3 times.
And guys, what's 2 times 2 times 2? 8. What's 3 times 3? 9 times 3.
27.
So that's all that is on that one, Janaya. There's a little bit more to this one, but remember I said I'm not going to sweat you understanding where that 1/2 exponent is coming from. I just need you to understand that a logarithm is equal to an exponent. So the exponent of 1/2 on the 16 gives me 4. Okay? So then we have 9 to the 3/2 is equal to 27.
Yup.
2 to the 8th is equal to
X.
x.
Yup.
Log base 6 of 36 is equal to x.
Yup.
That's it.
That's easy, bro.
You know that,
It's
boy.
just taking that logarithm, rewrite it as an exponential, exponential as a logarithm. Well, it's already given.
Yeah, I know, but
I
like,
know you didn't.
isn't it the same thing?
Yeah, those are equivalent,
36
right?
on the wrong side.
Base n, exponent 5, 243, my output becomes my input. Okay?
I literally tried to tell you that.
Alright. Can I what? I was saying, Jade, I know you had some questions.
2, 8
So
hours.
questions?
I did not write those.
What are you confused
That's
with?
log 6, 36 power. X. I was just trying to make sure you perfect. So,
Right
you
here.
gotta take it back.
The base of an
You
exponential,
gotta
right,
be perfect.
is what is raised to a power. But the base to that power, right? The subscript here is my base. See how those are both B?
Why the X so high?
Cause it's the highest number.
Okay, do you understand that this is my base? And you understand this is my base? And don't forget, this is an exponent, and what is a logarithm equal to?
It's a power.
So if you know all those pieces, there's only one other space for things to go. On top of the fact, remember what was my output becomes my, and what was the input becomes my
Output.
right? But remember, they're just inverses. So the inputs and outputs transpose. And if you can remember that a logarithm equals an exponent, there's my exponent that matches this exponent. There's my base that matches this base. This output matches this input. So remember, inverses transpose my inputs and outputs. Remember, that's an exponent and that's an exponent.
Would you ever have the
A
one?
logarithm is an exponent. Yes, ma'am. Say it again, Janaya.
I said the one is at the very bottom. Would you ever have that one too?
This one down here.
Yeah.
I mean, look, into the 5th. Oh, by the way, I need to emphasize this because I saw some of us miswriting these things. I need us to recognize this. First off, if I'm rewriting this as a logarithm, and so this is literally what I do, Jacob. I need the base of this logarithm. I say the base is the base. The 5 is my what? So if you can label that exponent base, and remember this is my output, so it's going to become my input. So log base n, right? My output becomes my input, and that's equal to my exponent of 5. That's evidence of understanding, but also like it helps you write everything out because you know what your base is, you know what your exponent is, and then you know your output becomes your input. But let me point this out really quickly. I need you to notice this. This is not, right here, this is not a time that I would actually ever use a logarithm. This would be right here, because what is my unknown in this equation? An x, right? It's an exponential. So I take log base 6 of both sides. Weirdly enough, I'm still teaching and talking. I don't know why you're talking. So x is going to end up equaling 2 because 6 squared is 36. You don't have to have written that yet. I'm just pointing that out. Log, that is going to equal 2. But right here, is this an exponential when it's into the 5th power? No, that's a power. What's the inverse of a raised to the 5th?
Raised to 6.
What's the inverse of a square?
Square root.
Square root. What's the inverse of a cube?
Cube root.
What's the inverse of a fourth power?
Fourth power root.
A fourth root.
Oh.
So it's going to be the inverse of a fifth power.
Fifth root.
So if I have a power,
So why is it?
I'm going to use a radical.
divided by 5, right?
Not divide. Division is the inverse of multiplication.
I don't want to.
The inverse of a power is a root. And so what was multiplied 5 times to get 243? 3 to the 5th is 243. Now you can put it into a calculator to get that. But remember, division is the inverse of multiplication. This is a 5th root. Yes, Janet?
Is the number outside the root dividing or multiplying?
Neither. It is the root. Okay. Bless you. Okay.
Here's some cooperating point. I need to tell cooperating point.
You over here. Oh.
Okay. Nope, that's not what I was doing. Page 204. Apparently I didn't put it in the slides. But I know I didn't put it in the slides. So go to page 204 for me. Okay. Hold on. Sorry. Someone's calling me for this. Alright.
Answer the phone.
No. If they call again, I will, but I don't, it's the same person. Please call me while it's okay. Ladies and gentlemen, 204. Sorry. Yeah, 204. So, 2 to the x minus 5 plus 6 is equal to what?
30.
30? Okay.
Okay. What page?
So, 204.
Yeah, he put.
I know, I messed up, I didn't put this in the slides. Okay? So, right here, what I need us to think about is this. If I want to solve this equation, Jacqueline, how many times do you see the variable in this equation here?
What?
Once. So what can I use, Simone, if I only see the variable one time? Simone, what can I use if I only see the variable one time? Inverses, right? Hey guys, if you only see that variable that you want one time, what do you use? Inverses. So, when I look at this equation, KK, do you know what inverse I'm going to use right here?
I won't say it wrong.
Well, have I ever been upset when someone gets it wrong?
Nah.
Subtract.
He still ain't nobody saying it. So somebody can say something.
Subtract.
What? Subtract what?
6.
What do y'all think about subtraction 6? It works? Why would subtraction by 6 be what I do here?
They count.
I am trying to get the variable by itself, but why the minus 6? Why not anything else first? Why not plus 5? Okay, the last operation being done is the first one I want to undo. Right? When I look at this x, it's x minus 5. Then it's 2 raised to the x minus 5. Then the plus 6. So, okay. Yes, Chandler. Because I want to solve for x, 30 is on the other side of the equation. I want to get rid of the stuff that's near the x on the left-hand side. So, this is the only thing that's different than what you've done in the past. Trey, what would be the inverse that I use now?
The inverse?
Uh-huh.
For which one?
To solve this equation.
No.
Okay, why logarithm?
Cause you only got one, I don't know what to call it.
But well, what would we call this? This is an exponential. It's got a variable in the exponent. So now that I have an exponential and that's all I got, I'm going to use a
No.
whatever I do to one side of the equation. Now, yes ma'am. Because these are inverses, right? So I canceled out the base and I just left with the exponent. Another way to think about this, if you don't like that, let's say I just want to rewrite this as a logarithm. I'm going to rewrite it as a logarithm. What base would my logarithm be? 2. The output is going to become my and a logarithm is equal to, and see how that gives me the same exact thing? So you can do that, or you can write it, it's transposing, right? So, now I don't know what log base 2 of 24 is.
So now that's your answer.
Log
Well,
base
I still need to know what x is, right? So, does anyone know what log base 2 of 24 is off top of it? Is it? Is it division? I thought a logarithm. Well, hold on. What is a logarithm equal to? It's an exponent. So, like, if I were to do 2 to the third, what do I get?
3.
8.
Oh, 2 to the third.
2 to the fourth
What?
times another 2 is 16. 2 to the fifth. 32. Notice how 24 is somewhere in between there?
Oh, it's like
4.5.
So it's going to be 4 point something. I don't know exactly what it is, but instead of guessing, let's go grab calculators. One person per group, grab calculators for the whole group. And not throw my calculators all the way across the room, girl.
Let me see that, bro.
Dang, that hurt to hear. It's fine. Grab a calculator. What's up? We're about to
Oh, so I'm just doing inverse. If I do an inverse, then I'm doing.
Is that right for B? Okay, C
It's okay, I wrote
was 4
half.
to the x minus 3. Minus 5. Okay. My God, we're literally about to go over it. You see me writing on the board? No. Alright, so let's talk about these two.
Hold up, bro.
Not hold up.
All I did was
Dewan, you literally were typing on an iPad instead of doing the problem.
that said that.
Who said hold up then? My bad, Dewan. Hey, Dewan. When I apologize, chill, dude. I make mistakes. Do you make mistakes? Do I go in on you when you mess up?
I'll make no mistake.
No, that's a lie. We're about to go over it.
I got it right.
So, right here, let's look at B. Remember, if I only see that variable one time, what can I use?
Inverse.
Okay? So, read the equation. Read what is happening. What is happening to x? It's being multiplied. What's happening to 3x? It's being was 2 to the 3x. By the way, that means right here is my what? Exponential. So when I get there, what am I going to have to use? Logarithm. But then I'm multiplying by 7. So I'm just going to divide by 7, guys.
Oh.
7 divided by 7 is? 1.
Wait, I got wait, hold on.
That's what I did.
Nah, this is
Wait, I'm just what?
Girl, what's the inverse of multiplication?
Division.
Okay, so what did I do?
I don't know.
What's
divide.
the fraction bar mean? Okay.
No, so oh, you divide by 7.
Yes. Isn't that what I'm multiplying by?
Yeah, but how do you want?
Wait, Mr. Kenny,
Ma'am.
is that like a 1 in front of that 1? Like a 1 half?
You can also use the reciprocal, which is what I usually use.
Okay.
Well, you can.
Yeah.
Sean, what am I now going to do to solve this equation?
Uh-oh.
What? Log it. I got an exponential. What's the inverse of that exponential? Logarithm? Mason, what base am I going to use for this logarithm? Base 2. That's it.
2.
Slow it
I
down.
want to put it in.
5. Oh.
I don't need no calculator. I do it with my mind.
So, hey guys, what's
906.
log base 2 of 20 is 6 point what?
6.906.
Yeah. I hate it all, y'all.
Okay. Hey, so Cam, what's happening between that 3 and the x? They're being multiplied. So what am I going to do to undo that multiplication? So reciprocal or division? 1 divided by 3.
Reciprocate.
Hey.
302.
Brain power.
302.
Okay. By the way, guys, how can I check to make sure my solution is correct?
You don't eat no chocolate.
We gotta do the Y, no, not Y.
Hey, remember, what is a solution? It makes the equation true.
I got a question.
So could I substitute this back in to see if it makes the equation true?
Yes.
Okay, can. Now, I will say this. Don't type out the full equation, just type it out here because it's only going to be approximate, it's not going to be exact. But it'll be very close to 840. Pam, what's your question?
But can I go to work on shit like that?
Hold on.
I ain't gonna care, I gotta go again.
Did she tell you what I did?
I got this though.
I'm about to do one more. That's a slightly different table. Alright, I need us paying attention to this because this is one detail that's different, but the conversations I heard, most of us picked up on this detail. So, right here, Nate, what type of expression do I have on the left-hand side?
Oh, exponential.
Exponential. So Chandler, what am I going to do to undo that exponential? A logarithm. But Cam, what base am I going to use on this logarithm? The base of the exponential is 4, so the base of the logarithm is 4. So x minus 3 is equal to? Log base 4 to 21, which is about...
Wait.
2 point something? 2 point...
2.19.
Do we have to do like that?
What do you mean?
Oh, yeah. Oh, yeah. I got it right.
Like what, Drake?
Got it right. Yeah, I saw it.
What? No, the 20, where's your 21? You put 16 instead of 21. And you don't put an equal sign there,
That's
right?
awesome.
Okay,
Move your big old head.
hey,
Hey, don't talk small like that.
Flash your mouth.
so,
We better.
Now you're my way.
we're about to.
Okay, I can. Dude, why
I
is
told y'all the wrong
this
page.
down here?
I know that's right. Alright, really quickly, we're just going to look at 1 with 213.
Before you start, you come out.
No ma'am, I can do it in a second. Okay.
That was kind of crazy.
Page 213.
Just stay down.
I will look at it in a second, Cam, after we start the demonstrated understanding. Yes, Chandler. Say again.
You did before. He said 215.
Okay, I'm going to do something nice for y'all that I don't normally do, and I'm going to leave these problems on the board during the demonstrated understanding because we haven't done them much.
Wow.
You got it.
We're going to demonstrate to understand.
So, right here. What's different with this equation?
It's already wrong.
It's already a logarithm, right? But what do I need to do to solve this equation then?
Log it.
It's already a log.
Inverse it.
Unlock.
So what? Yeah. So what is the inverse of a logarithm? Exponential.
We go exponentially.
So, and that's, we call it the anti-log, but that's basically it. What I do is 4 raised to this power.
Wait, so you put that, you put.
So you just gonna put a number in front of it.
Well, it's not in front. Notice this is a base 4, and this is an exponent, now a power.
So I'm just put my base in front of the exponent.
Which one is this?
Then whatever is page 213A.
Make sure you read that one.
And then whatever I do to one side of the equation, I gotta do to the other side.
See, I would have thought you would put the 1/2 in front of the log. Since you don't, so we can see like 1/2.
Okay, so I'm gonna show you one other thing, but remember, it's an inverse. It's the base. This is a base 4, so what base do I need to use? Right. And to know this, just type it into the calculator. This is that idea of a square root of 4, though, which is... So what would I do to finish solving this equation?
What did you subtract?
So we got to find x. What
I went ahead and told you, you would type this into a calculator, but that's the square root of 4, which is 2. Just type that into the calculator. Okay,
My boy Dewan corrupt.
now,
Did you get that song?
So we're not just trying to find out, we're trying to find answers.
we're trying to solve this equation, which is what x is. So, Janai, to help with this, remember, we looked at this earlier where we can rewrite a logarithm as an exponential, right?
Right.
So what would be the base of my exponential? The base would be 4. What would be my exponent?
Go out to eat or go home.
What is a logarithm equal? It equals
Go
an
home.
exponent. So it would be 4 to the 1/2. What was my input is going to become my, and that's exactly what we had here. So if you want to just rewrite it as an exponential here, you can.
And make sure
You
you have
can't
a board.
always, but here you can.
I need to pick that.
Okay.
Raise up.
We're trying to solve for x, right? And so we use our inverses to solve for x.
That's why I was just.
If you do anything, keep that one on.
Right, because the inverse of a logarithm is an exponential. So it's 4 raised to this exponent. 4 raised to this exponent. Okay. But notice what you can also do, this is an alternate way to do it, where I just take my logarithm and I know my base of the exponential is 4, my exponent is 1/2, and what was my input is now my, so you can just rewrite it as an exponential as well. Okay. No, because we're gonna go over it tomorrow, but I'm gonna leave this on the board. No, quickly. All right, ladies and gentlemen, you may keep out your Frere model, and I will keep both Frere models, the inverse one and the logarithms one. And I'm gonna leave those problems on